We are going to be graphing radicals. And what does that mean? Well, that means graphing this. Y equals the square root of x. This is our parent function, kind of like y equals x or y equals x squared or y equals a to the x power. So we're going to do what we always do when we encounter something like this. We're going to go ahead and we're going to make a table. So x and y, and we're going to run down here. And we're going to start off with nice things like 0. What is, when x is 0, what is the square root of 0? Square root of 0 is 0. When x is 1, what is the square root of 1? Well, the square root of 1 is 1. Now, it's going to get a bit interesting here because what's the square root of 2? Well, it's about 1.43. What's the square root of 3? Well, it's about 1.72, I think. But our next major number that's going to be relevant here is going to be 4. What's the square root of 4? It's 2. And we can kind of follow this down. What's the square root of 9? Square root of 9 is 3. So we can go ahead and graph this where we have this point right here and a point right there at 1, 1. And then we have a point at 4, 2 and a point at 9, 4, 5, 6, 7, 8, 9, 3. So right up there, we draw these together and we get something that goes kind of like this. And what you'll notice is if you took this and turned it 90 degrees, this would look a lot like a quadratic, the graph of y equals x squared, but only one half of it. So now we've got to go the other direction, and we got to put in some negative numbers. Well, negative 0. No, not negative 0. Negative 1. So we put in negative 1. Well, there is no square root of negative 1. You can't multiply anything times itself to get the square root of negative 1. So our answer here is nope. And negative 2, again, nope. Negative 4, negative 6. So actually, as far as our graph goes, this is all that we see. This is the whole picture of what it is. You'll notice there is nothing over here at all, and there's nothing down below the line down here. And so that's well, the interesting piece of this is we actually now need to really look at, and it becomes relevant, what's our domain and range. So our domain is all acceptable x values, and in this case, x has to be greater than or equal to 0. Because x right here, x is all of those numbers are fine, continuing off that way. Meanwhile, our range, y, will essentially be all of these numbers. So our range is going to be y is greater than or equal to 0. And so, because as this continues off to the right, it's going to slowly increase y, and eventually we could get any number, but we can't get any negative numbers for either x or y. Now, like we've seen before, what does this look like when we start adding some things on? So y equals square root of x plus 2. Well, just like we saw before, we're going to see a very similar result here where what's going to happen, x and y, we go ahead, we put in 0, and what do we get? We get square root of 0 is 0 plus 2, so 2. We put in 1, and we get 3. We put in 4, and we get 4. Now, interestingly, if we put in negative 1, you might think, oh, we add 2 to it, it's fine. But it turns out we still can't do that right here. We can't actually plug anything in. Can't plug a negative number in there. So when it comes back to this, we get nope. We still can't plug in a negative number. So what have we done here by adding our plus 2 right here? All we've done is we've taken our previous graph, and if we look at this, we see right here where it is. We're going to take it, and we're just going to move it up 2. So it's going to go something about like, I didn't count that out perfectly, but there's one yeah, let's redraw that and put some dots there like an adult. So we got a dot right here, we got a dot right here, we got a dot there, and we're going to get 9 is going to be 5, so 4, 5, 6, 7, 8, 9, 5. Now we can go ahead and try to draw a straight line. I really should be doing this with a better tool. There we go. Okay, so, and now we have, oh, I'm still on an eraser. There we have a line that works a little bit better at least. So again, if we add 2 right here, what's going to happen? It's going to go up 2. If we subtract 2, right, if we switch this and instead it was minus 2, well, we just go down 2, and you might be thinking, but we can't have negative numbers. Well, we're still plugging in, if it's minus 2, we'd still be plugging in 0, and then taking away 2 from it, so we would end up with negative 2. So we can still do that in that case. Now, I want to show you one more major change on this, which is if we have y equals the square root of x minus 2. And you might be thinking, oh, well, there's a negative number in there, we can't do it all. Well, there are some things we can do that will actually give us positive numbers. So here's our x, here's our y. So first off, if we plug in 0, what's going to happen? Well, square root of x minus 2. X minus 2 would be negative 2. We cannot do that. So nope, the answer there is nope. What about a 1? Plug in a 1, still a nope. But here, we plug in a 2, and what do we get? 2 minus 2 is 0, square root of 0 is 0. We plug in a 3, 3 minus 2 is 1. So we end up with the square root of 1, which is 1. And then if we plug in, and I'm going to jump up a little bit here, I'm going to jump all the way up to, if we plug in 6, what's going to happen? 6 minus 2 is 4, square root of 4 is 2. So what we've really done here is, once again, we've taken this exact same shape that we've seen in all of these other examples, and we've just pushed it over to the right. And it hasn't really changed much beyond that. So here we added plus 2, that moved it up. We subtracted minus 2, that moved it down. We come over here, we put that minus 2 inside the parentheses, or inside the parentheses, or inside the square root, and that moved it to the right. Again, what do you think is going to happen if we go for the square root of x plus 2? Well, in this case, we could actually plug in a negative number. We could plug in negative 2, right? And if we plugged in negative 2, what we would see is negative 2 plus 2 is 0, square root of 0 is 0, and we'd get 0 out right there. So we'd be able to essentially plug in negative 2 and get 0, and we'd take this whole thing and we'd just go ahead and move it to the right, to the left instead of the right. Final crazy thing I want to talk about on this, and I know this is kind of a long video, but this is an important one. So the square root y equals, I'm going to erase that and do it all prettier here because I ran out of room. Y equals the negative square root of x. Now you might be thinking, well, negative sign, but that negative sign's outside of the square root symbol, so we've got, we can plug in anything, and basically what we're going to do is we're going to go back to the original, our first, went the wrong way. We go back to our original y equals x, and we're just going to flip the sign right here on all of these. So still can't get an answer here, still can't get an answer there, but these are just going to be the opposite. So from 0 becomes negative 0, negative 1 becomes, or 1 becomes negative 1. So in this case, when we plug in 0, we still get 0, negative 0, and 0. When we plug in 1, square root of 1 is 1, but it becomes negative. 2, square root of 2 is 2. Square root of 2 is the square root of 2, but again, we get to 4, and it's square root of 4 is 2, so we plug in that and we get negative 2. So we're doing the same thing, but what's happened? Well, we've taken it and we've moved it upside down like this. We've flipped it across the y-axis. Now, one other thing, and this is the last piece of this, and I'm going to write this up here so I have room to do it. Y equals the square root of negative x. Now, you might be going, there's a negative sign in there, we can't do it at all. Well, what's going to happen when we put in negative numbers? We put in any positive number, it's not going to work. But if we put in 0, negative 0 is 0, so square root of 0 is still 0. We put in negative 1. What is negative negative 1? Well, negative 1 is 1. So, square root of 1 is 1. What happens when we put in negative 4? negative 4 right there. Well, that'll be, we will get the square root of negative negative 4. Negative negative 4 is 4. Square root of 4 is 2. So what have we done here? Well, we've taken 0, 0, so we got that point right there. We have 1, negative 1, 1, and we have negative 4, 2. And you'll notice we've just basically taken this and rotated it over that way. Now, just for fun, I'm going to show you this. What happens, do you think, if you do y equals negative square root of negative x? Well, in this case, we're going to flip it both ways. We're going to flip it over, right? So our purple flips across the y-axis. Our black here flips across the x-axis. This is just going to be both, where it's going to go like this. So those are the pieces of how to go ahead and graph this. Really importantly, you're paying attention to what can and can't the answer be. Sometimes you'll have answers that it's x can be positive, y can be positive. But once you start moving it around, we want to look at some of these domains and ranges and really pay attention to what x can and can't be. We go back over here, we've got some weirder things as far as what x can be. In our main example, x has to be greater than or equal to 2, but y is still greater than or equal to 0. Meanwhile, our yellow would be y is greater, x is greater than negative 2. We come back over here, and we've got our domain and range. Our purple domain, x is greater than or equal to 0, and y is greater than or equal to, and in this case it's 2. It can be 2 or greater. So it's important that we actually think about our domain and range in these, because they really do play a pretty important role.